This is the quarterly plan video for BrainPoints in spring of 2017. The project goals of our project will be to improve people's coding habits and their desire to tackle challenging coding problems by using BrainPoints. The motivation of this problem is that Nell's recent research and other recent research on building a growth mindset with BrainPoints has shown to improve motivation and excitement about challenge in the sphere of math. We'd like to see if this translates from math to computer science. This quarter, our goal will be to conduct studies to better understand how to detect the growth mindset. If successful, we want our end users to have a prototype that encourages them to use good coding practices and instill a desire in them to tackle challenging problems without giving up. This will be a way for others to be able to detect the growth mindset in coders, and also allow us as researchers to understand what the growth mindset looks like in computer science from keystrokes and user behavior.
Our research goals for this quarter we're going to talk about next, and so the research questions that we are going to try to answer are: 1, what does exhibiting the growth mindset look like when an individual is programming? For example, what does productive versus unproductive struggling look like? 2, how can we automatically detect user behaviors that signify effortful actions that are conducive to developing a growth mindset in introductory programming? And 3, how can we encourage the growth mindset in a programming environment? These questions are really important to focus on now because the number of people learning to code is growing rapidly. In addition, the gender gap in computer science is also increasing, and there's a lot of recent research in relation to BrainPoints in the math setting, and we would like to translate that to computer science. We hypothesize that some good coding practices include proper debugging, documenting code, writing helper functions, etc. And BrainPoints or other similar methods of teaching of the growth mindset will build retention and interest in coding. So our first design argument is we hypothesize an individual with a growth mindset will take long pauses to think about the process of what they're doing rather than just starting to code immediately, and that they will also have less repetitive code because they will have thought through the problems more. Whereas someone with a fixed mindset will be typing more consistently because they are just trying things randomly without taking time to fully understand the problem they are tackling. In addition, they will probably copy and paste more often, both from their own code and code they find online. Our second design argument, we hypothesize that using a combination of heuristics that we define from observations and machine learning by running classifiers on features designed from users' keystrokes will provide us with a way to automatically detect whether or not an individual has a growth mindset while programming. To confirm or reject these hypotheses, we will have 2 studies. In the first, we are going to collect information that will help us determine how to detect the growth mindset. And to do this, we will ask participants to do an easy task, then a hard task where they'll flail and perform an easy task again. And we will look to see how people with a growth mindset versus fixed mindset code differently. And additionally, we will then use a combination of heuristics and machine learning to create a coding platform that identifies if someone has the growth mindset by collecting their keystroke data. In the second study, we will have 2 groups and ask them to perform the same task. One will be the control, rewarded based on progress, and the other will be rewarded with BrainPoints. There will be a mini challenge or final challenge that may be skipped at the end, and basically if you choose to complete this challenge, that's more inconclusive that you may be more of the growth mindset mentality. And using the study, we'll be able to confirm or reject our hypothesis based on if the students with BrainPoints completed the challenges more often than those in the control group.
For design goals, we have the user problem, design argument, and design process. The user problem is most teaching environments praise getting the correct answer when coding and not necessarily coding well. So our design argument is if you want to teach the process of coding, then you are best advised to give the intervention the characteristics. 1. Reward the right process of coding rather than the right answer. 2. Provide manageable challenges. Because of arguments 3, people are scared of failure, but coding is about trial and error, And 4, BrainPoints have been shown through studies to make people more excited to be challenged and learn within the product longer. Our design process is first paper prototyping, then user testing, and then prototyping. Our timeline for this quarter is after we figure out how to detect coding behavior, which is in the first user study, and that study with data analysis will take about 3 weeks. Then we will create a prototype the 4th week, test the 5th week, improve the 6th, and then conduct a final test. We will conduct our first test on EECS 295 students recruited through the class. We will conduct our second test on a variety of different EECS students from Northwestern. For technology goals, by the end of the quarter, we hope to have working technology that can detect the level of growth mindset someone is exhibiting at a given time. This will be an Atom package. The components will be, first, a marker indicating whether or not the user is earning brain points. Second, suggestions for improvements of user coding techniques. And third, a file that saves data.